By Kirsi Lorentz from the Cyprus Institute. The floor is yours, Kirsi.
Thank you so much. And it's a real pleasure to be here. Let me just get the presentation up for you. And then we go to the presentation mode. Okay. Right. Let me just actually go to the very beginning. Okay. Can I just double check that you can see my slide in presentation mode and you can hear me?
Not yet the slide. We see your desktop, I think.
Ah, okay. Let's stop sharing. On my computer, it shows that it's okay. So let's try again. Wonderful.
Thank you.
Okay. So thank you very much for having me. And whatever time it is in your time zone, participants, very happy to be here today with you and happy that you have been able to join. And I look forward to engaging questions at the end of this presentation. So do jot down questions as we go along. And cultural heritage is, of course, something that we all know at least a little bit about. It is our common human heritage. And it's the synchrotron radiation applications that we will talk about today in terms of looking at what we can learn from the key questions as to our past and how synchrotron radiation facilities have a role to play in this, but also vice versa, how cultural heritage research can help in communicating the important role that synchrotrons play in our current world. A people without knowledge of their past history, origin, and culture is like a tree without roots. This is what Garvey said. The image there shows the Roman city of Jerash in Jordan, where the Sesame synchrotron is located. So heritage is really about grounding us. And we'll look at a little bit what cultural heritage is. Then we move on to looking at the role of synchrotrons in cultural heritage research, particularly with the examples of Sesame and the African Light Source Initiative. And then we'll dive into looking at the specifics of synchrotron radiation techniques applied to cultural heritage questions, some case studies, and finally, look at the importance in mentoring of mentoring and teaching. And all of these domains, these aspects, I hope find resonance also with what you are engaged in your specific domains. There are a lot of touch points and a lot of common issues that we can discuss. So, what's cultural heritage? It's an expression of the ways of living developed by a community and passed on from generation to generation. And here's a list of aspects that it could include from a particular encyclopedia. Cultural heritage often brings to mind artifacts, historical monuments and buildings, as well as archaeological sites. However, the concept is even wider, as you see there. Different kind of documents and so on. Towns, underwater heritage, natural environment, and so on. But also intangible cultural heritage, oral traditions, performing arts, rituals, and so on. So not just what we can touch, whatever scale that is in, but the intangible as well. So not only limited to material objects, but also the intangible. Now, archaeologists, of course, often have access, especially in the prehistoric context, to the tangible in its great majority. And even through texts and such sources, we always need to exercise source critique when we try to access the intangible. Now, why are synchrotron radiation approaches crucial for the study of cultural heritage? Some of this relates to the characteristics of synchrotron radiation techniques. Non-destructive, non-invasive, or perhaps better put, minimally destructive, minimally invasive. Some reversible changes, perhaps. Structural to chemical imaging, so we have a really wide range of different types of data, and this is really critical when we look at cultural heritage artifacts and samples, which are often very heterogeneous, and the questions are rather complex. Someone very wise put it very aptly, I think. Archaeological sciences is the application of all humans' current knowledge and techniques to understanding all humans' past knowledge, techniques, and life ways. So here's some of the UNESCO World Heritage Sites in the Eastern Mediterranean and Middle East region. And the color coding legend is in the corner there. The red points denote World Heritage in danger. And why I put this here is just to bring home that for some sites, for some remains of the past, it's really a critical hour. So we need to use synchrotrons like Sesame and other synchrotrons globally to explore the cultural heritage while we can. So here's a number of such sites just to show you the diversity of remains, monumental remains. And in each of these sites, of course, we have a plethora of artifacts, in some cases documents, traces of life, and looking at those traces, whether it is in Persepolis, Babylon, Qasr al-Farid, Petra, Byblos, or our own Hirokitia here in Cyprus, is facilitated by use of new approaches, and in this case, synchrotron radiation approaches, which are continuously evolving and being developed, as you've heard during this training school. A number of other sites here just to showcase the diversity, the scale, and so on from that particular region. And then moving on to the African continent with the same denotation in the legend there as to the sites and the red marked sites in danger. The African Light Source Initiative is particularly important for providing the continent with the data required. And here's some of those sites to showcase, again, the diversity of the type of sites. Whether we're looking at landscapes, monuments, remains of biological nature, structures, and so on. And here I will just flip through the references so that we are in the good side of things. So let's look at the role of synchrotrons in cultural heritage research, Sesame and African Light Source in particular. Interestingly, the Eastern Mediterranean and Middle East is known popularly as the cradle of civilization. And the African continent is known popularly as the cradle of humankind. So both regions are rich in cultural and natural heritage, and increasingly this connection between cultural and natural heritage is being made in several different contexts. Now, you already have heard quite a lot about sesame, so I won't go into detail on this, but what I did want to mention is that sesame opened its doors with research on cultural heritage, the first being time. Here's the current beamlines. Again, you have already heard quite a lot about it. And in the context of the African light source, heritage is particularly also mentioned in terms of the potential for African science with light sources, paleontology and archaeology. It's a symbiotic relationship. It's a win-win. Synchrotron radiation techniques help to answer key questions about our past, and synchrotron radiation-enabled research on our past helps to communicate the importance of synchrotrons, engaging diverse and wide audiences. And earlier today, we heard a wonderful talk by James Gillies on the importance of communication. And cultural heritage resonates with different audiences, wide audiences, from decision makers to stakeholders to future generations as growing around us. So let's look at some of the details in terms of synchrotron radiation techniques for cultural heritage applications. There's a multiplicity of techniques, as I already mentioned. There are different beamlines dedicated to different characterization techniques. Here's just a list to showcase the variation between different synchrotrons worldwide, as shown here. And for example, at ALS, here's a schematic representation showing different types of beamlines, as well as for Soleil synchrotron. And the importance there is teamwork and communication between the synchrotron radiation technique specialists and the cultural heritage specialists, so that together as a team we can explore which key questions require which techniques. And I purposefully use the plural as very often we need a number of techniques to address questions. And of course, I should mention here that the key thing, as always, in obtaining beam time at synchrotron facilities is to exhaust all other possibilities in the laboratory context, showing very clearly in the beam time proposals that synchrotron radiation is absolutely necessary for answering the particular key questions at hand. And even in that process, it's really important to engage with the beamline scientists. So core techniques that often appear in the context of synchrotron radiation enabled approaches to cultural heritage and archaeology include micro-CT, infrared spectrum microscopy, X-ray fluorescence spectroscopy, as well as X-ray absorption fine structure. And there are further techniques such as SAX, XRD, and so on. There are many relevant beamlines worldwide. Here, a publication from 2021 by Giannoncelli and others to showcasing in table format the different beamlines used for cultural heritage. Sesame synchrotron has 4 core techniques available for cultural heritage applications: infrared, XRF, XAFs, and micro-CT, SXCT. And this is a really wonderful context because then one can really explore different types of materials with those key questions in mind, ranging from pottery and ceramics to artifacts of unknown materials, plant remains, animal remains, human remains, and so on. And synchrotron radiation on material remains from the past is best employed when we really are using it to answer key questions about the past. Characterization is one thing, but we really need to have a context where it makes a difference to produce those critical results, that critical data that enables us to explore key questions, whether it is about manufacturing techniques, degradation, preservation, aspects of human population variation in terms of, for example, dental development and so on and so forth. So some of those types of context of use are shown in the slide under specific different types of materials. Let's look at SXCT or computed tomography micro-CT with synchrotron source. This, of course, provides data on structural imaging, and we can explore aspects from pathologies in animal and human remains, virtual histology, all the way to aspects of manufacturing, degradation, and preservation in different types of materials. A range of sophisticated imaging techniques have been developed in the recent years, both in the lab and synchrotron contexts and in other transnational facilities. Synchrotron sources have several advantages. There's high flux, brilliance, and temporal and spatial coherence. And development of high resolution detectors has made it possible to implement X-ray radiography, microcomputed tomography, and phase contrast tomography for cultural heritage research. And here's some of those studies. I will go through these relatively rapidly, so we have time for some discussion and questions at the end. For example, tooth cementum annulation is used by anthropologists to decipher age at death and stress periods based on yearly deposit incremental lines in the tooth cementum. And in this case, ID 19 was used at ESRF by the group referenced in the bottom right corner. Here a little bit of more detail showing the cementum, the outer part there, and the dentine. Another entirely different context of application within the context of cultural heritage is this violin, a historical violin. And it's the synchrotron approach in terms of SXCT, micro-CT analysis, allowed identification of the internal wood grain pattern unique in each instrument. And this is particularly important in terms of verification of authenticity and in the context of protection against loss, forgery, and so on. This work took place at Elettra. Here, another study, historical architecture in Korea, wood identification. So virtual histology of wood from a historical building. And this work took place at Spring 8 in Japan. Imaging of the wood samples at high resolution, and this enabled the wood identification. Textiles can also be studied, as in this study relating to material from Italy, and the particular copper corrosion phases that researchers looked at in this case. Differentiating between whale bone and terrestrial animal bone was the focus of this particular work by Vercouter et al. and it's a very important differentiation in the context of understanding the ancient Paleolithic lifeways. Plant remains, particularly in terms of seeds and looking at, in this case, the Indian horse gram, the domestication. So looking at the thinning of the seed coat, and that is important in the context of exploring domestication, which is, of course, one of the key questions that archaeologists have been focusing on for more than 100 years in different regions of the world. Microfossils is another type of remain that has been looked at, showcased here. Let's look at infrared next. So infrared can be used to characterize compounds. And here the example comes from Elettra, looking at paintings, looking at identification of binding media, as well as identification of different compounds and their localization, pigments and the technology used to prepare them, alteration and corrosion layers, identification of organic coatings to protect silver, the metal foil, gluing layers, and the reaction compounds in altarpieces, and so on and so forth. There are many, many studies in this domain. Infrared can also be successfully applied to identification of pigments in varnish layers, of musical instruments, determination of adhesives used on fibers or of traditional costumes, and so on and so forth. And here are a few other case studies for your information with references to follow up. Infrared can also be used to look at human remains and evaluating long-term alterations, both in terms of the human animal as well as non-human animal remains. And this is critical in terms of the process of selecting samples for often destructive analyses that give key information on isotopes and so on and so forth. X-ray fluorescence. Synchrotron radiation, a micro-XRF, enables mapping of localization of metals, whether it's in material culture, human bioarchaeology, animal remains, or plant remains. And I'm particularly interested myself in human heavy metal exposure. In the past, the exposome has become more and more important in the EU context as well, with new funding calls coming up on this domain, both in the present context and features very, very high up in the challenges of the World Health Organization as well. So that also showcases the relevance of archaeological research enabled by synchrotron radiation facilities to our current challenges in our current world. Here's another type of example: manuscripts, and particularly a palimpsest context where a text that the original text on a document, not visible currently otherwise, has been coaxed out with the use of synchrotron radiation XRF. In this case, an underlying older layer of writing was discovered. The combination of different synchrotron radiation techniques is very powerful. Whether we're looking at, as in this case, on glass beads from Thailand, looking at chemical speciation following the observation of chemical elements, or papyri, as in this case, where we have multiple laboratory techniques as well as synchrotron techniques combined into a really powerful toolkit to look at an ancient manuscript. Let's look at human metal exposure in the past in a couple of contexts. And again, you can follow up in more detail if you wish. So as mentioned, synchrotron radiation micro-XRF enables mapping of the localization of metals found in cross-sections of, for example, human hair, which, as you may appreciate, having kind of a reference sample on your head is very, very small in size, and this type of data really cannot be obtained in the laboratory. So what is important when we're looking at archaeological and cultural heritage material is to appreciate what is biogenic, what was ingested, inhaled, or absorbed through the skin and then made its way to ancient human tissues, biogenic, from the diagenetic. Of course, these remains have been, so to say, sitting in the soil, in some cases for thousands of years, and we need to account for diagenetic changes. And therefore, it is really important not only to be able to identify whether there is metal element content, but also to be able to localize and to explore in this way the question of whether or not we're looking at biogenic or diagenetic changes. So in this case, the site of Şehresuhte, which translates as the burnt city due to the traces of burning in some of the monumental architecture there, from the present-day Iran, I was able to obtain some human hair from this ancient site, over 5,000 years old. And this site is located along ancient trade routes, part of what we later term as silk routes. And it was a very, very large urban site with trade in precious metals, mining and manufacturing activity, including copper mining and so on. And so this slide showcases some of the approach together with the ancient hair samples. I was able to explore modern hair controls at the ESRF, the European Synchrotron Radiation Facility, and map the elements present at the ID21 beamline. And I would like to acknowledge the facility as well as its staff for this very fruitful collaboration. And we can use certain elemental maps to identify different structures in the hair, the cortex, the cuticle, and so on. And we can look at the copper levels. And one of the outcomes here will be shown in the next slides, but the importance of this data and the key question really that I'm interested in here is understanding human health in periods and sites with intensive metallurgical activity. And metallurgy is, of course, so very important for our human history and human past that we have even named the archaeological periods according to metals. You're all familiar with Copper Age, the Chalcolithic, the Bronze Age, the Iron Age, I am sure. So looking at these great changes and innovations and the technology and exploring the potential health consequences in this context exploring the potential sources of exposure in the past, and again referring to the current interest in the human exposome, lifetime, and providing the depth in the la longue durée, if you like, in the deep past, on the story of human metal exposure. And of course, there are different routes through which unwanted metals can find their way to the human body, whether we are looking at inhalation, ingestion, or absorption through skin. So in the top right corner, you see the different samples, and the one with the most red there is a young female, 18 to 20 years old at death, or rather the hair strand cross-section from this young female, one of those analyzed. And the result from this sample is really significantly higher. All individuals on the site seem to have some background exposure, but particularly this individual. And of course, we have multiple different interpretations, and I'll let you ponder on what you would find most sophisticated, logical, or simple. All criteria when we're looking at our interpretations. Whether this young female may have engaged in some specific activity that others did not, perhaps in metalworking, perhaps using cosmetics that contained high levels of copper, or perhaps, as we know on the site, engaging in craft work using copper-based pigments, so on and so forth. Probably less likely that it would have been legacy soil contamination or coming through foodstuffs and water, as this could have been more widespread as to all the other individuals. So we have differential exposure here, which is really very interesting. I'll, in the interest of time, skip to the main results here and outcomes of the study. And it is of utmost importance here the ability when using synchrotron radiation micro-XRF to map the localization of, in this case, copper. And the ability also, of course, to do repeats so that we can be confident, relatively confident in our results. So another study, this time at the Sesame synchrotron, looking at material from the same site, but different remains, bones and teeth, in this case, conducted at the XAFS XRF beamline of Sesame. And I would like to again thank the facility and the staff there, particularly Mesaud Harfouch, for his role in this study, and of course in other contexts, Latif Ullah Khan, who both have delivered, of course, lectures and training within this training school. So here's some relevant images showing the vast site with its enormous cemeteries, with many tens of thousands of burials. Some of the contained
Kirsi, I cannot hear you.
You're muted.
Kirsi?
Yes, okay,
Good.
can you hear me now?
Yes, yes.
Yeah. Some message appeared on the screen mentioning that I was muted, but I tried to unmute, but I don't know what the
Okay.
blip was. You can hear well now?
Yes,
Yes,
yes. Do.
wonderful. So what I was just to maybe we go back to the previous slide. Some images from the relevant beamline at Sesame. And what I was mentioning there is we have this context of direct relevance for health, human health today. Heavy metal toxicity is one of the key challenges highlighted also on the World Health Organization materials, websites, and key challenges. And of course, in the European Union Horizon Europe upcoming calls, the human exposome in a wider sense is also one of the thematic foci under specific destinations under health. So here just one of the illustrations how heavy metal toxicity affects humans in the context of reproduction, normal growth and development is unfortunately the result often. So here's some of the data from the study. And I would just stress again that these type of studies to take place, it is very important to engage as a team with different experts, with people from different backgrounds to explore new ways of looking at old questions or synchrotron radiation techniques opening up entirely new questions for exploration. And here, importance of mentoring and teaching is, of course, paramount. So here's some of the examples from what we've been doing here in Cyprus at the Cyprus Institute, where I am based, running a postgraduate level course on synchrotron radiation enabled approaches to heritage sciences and archaeology. With cutting edge science in lectures given by Sesame Beamline scientists. And the assessment within the course is based on an actual beam time proposal draft that the students participating in the course do. And to my great delight, many of them submitted those drafts to in their final format after feedback to Sesame Synchrotron and were indeed able to obtain beam time of their own. And this all takes place within the master's degree program on archaeological science at the Cyprus Institute. Of course, we mentor also students from other domains across different science domains with material samples. PhD student supervision also takes place in this context, and I'm very happy to be able to state that the first postdoc now who has gone through this route is at Sesame at the infrared beamline, Yuko Miyauchi, who completed her PhD at the Cyprus Institute. And of course, mentoring takes place in multiple contexts, including getting involved in beam times of senior researchers, so student and postdoc participation in beam times at synchrotron facilities. And this is one way that we have found at the Cyprus Institute in collaboration with Sesame and other synchrotrons that works very well. Here's some images from a training school, both in person as well as online efforts. And of course, there is mentoring within projects, and these type of projects range far and wide from archaeologically and cultural heritage focused projects. And in this case, this €1 million project was funded within the domain of tourism. So thinking out of the box is often helpful when we try to look for opportunities. In this particular project, I was able to mentor double digits of people who have then gone on to postdoc work at synchrotron facilities such as Elettra. Now, feeder facilities such as the MicroCT walk-in hutch MicroCT facility at the Cyprus Institute, Biomera platform, can also provide mentoring opportunities. And new this year is the new infrastructure involving lab XAFs and XRF integrated into the MicroCT, as well as some added phase contrast capabilities. And I'd like to encourage any of you who are interested in mentoring opportunities and connecting with synchrotrons, including Sesame, to get in touch, whether or not you're in the cultural heritage domain or any other domain ranging from health to material sciences, because of course the structural imaging and chemical imaging capabilities are applicable in a very wide variety of domains. Here's another illustration. Comelis is focusing on correlated multimodal imaging and life sciences. And within this cost action and its follow-up, Comelis Globe, funded by the CZI initiative, further mentoring took place, and we're currently planning follow-ups. So new projects are, of course, on the way. So if you are interested in past or present human metal exposure, please do get in touch. Contemporary samples are, of course, of interest when we look at the human exposome in a wider context. And again, stressing the relevance of the questions that we ask in the context of the past to our present world, including to the UN Sustainable Development Goals. And as a take-home message, I'd just like to highlight how synchrotron radiation techniques are very versatile tools indeed for exploring key questions in cultural heritage. And it all comes down to teamwork, working together. And you, as participants in this training school, are in a key position in your institutions, in your future careers, as to act as multipliers in your research domains now and in the future, to take up the opportunities that synchrotron radiation facilities provide. So let's work together, and I look forward to your questions. Thank you for your attention.
Thank you for this really exciting talk. Very, very interesting. We've got a few questions. Maybe I can start and then we see how they develop. From Zahid. Many CH artifacts cannot be transported to a synchrotron. What portable or beamline to sample solutions are being developed to bring synchrotron techniques to museums or archaeological sites?
Thank you very much for this important question. This is, of course, one of the challenges when we're looking at very large monuments and large artifacts indeed. There are multiple challenges in terms of the transportation, whether it's logistical or permits and so on and so forth. Synchrotron techniques, of course, by definition require synchrotron source. So at the moment, I'm afraid what we need to do in cases like this is sampling. It is not ideal, but there are, of course, multiple other techniques, and that is what I didn't have time to go into, but your question provides a perfect chance to refer to it. Synchrotron radiation techniques are, of course, only one part of the plethora of approaches in our toolkit as experts when we start looking at materials. So when we can, we answer the questions using techniques in the field, instrumentation that is portable and particularly in our case at the Cyprus Institute, we have developed multiple sets of instrumentation and approaches, all the way from handheld to portable, in the sense of you can hoist it into a small car or a bigger car, or indeed a laboratory on wheels, a large truck with a payload of instrumentation. And in some cases, we're also airborne. We have unmanned aerial vehicles, if you like. So it's a really wide-ranging question, and one of the things that is really exciting, of course, at the moment is looking at what other developments there are. For example, in the domain of muons, I had the chance to visit Japan together with my colleagues from KEK recently, and there are very, very exciting developments that we can use, both in the field and in the transnational and national facilities. I hope that answers your question.
Thank you. And another question from Zahid. For natural UNESCO sites like ecosystems or fossil beds, what synchrotron techniques could be used, and how do they differ from those used for cultural sites?
Actually, the range of techniques is the same. When we are looking at structural imaging or chemical imaging, we are looking at a range of techniques from SXCT, micro-CT, to XRF, FTIR, and so on, depending from our question. If we're looking at organic compounds, for example, we'd be looking at FTIR. If we're looking at the structure, the shape, we might want to use SXCT. And I think your question really brings to the fore the importance of learning from each other, from different disciplines. I always say that archaeologists have to be good foragers, good gatherers, in the sense of gatherer hunters. We are gathering, hunting for the new applicable techniques, and so are our colleagues in paleontology. And it's also very interesting in this context to highlight that, for example, one of the key SXCT experts at ESRF, Paul Taffarow, is originally from the domain of paleontology. So I think there are really very interesting opportunities for teamwork and synergies, and discussing together the possibilities of application. And I think that's also very energizing. So I'd really encourage you to engage in that, and feel free to contact me also for further exploration.
Thanks. A question from Sonia. Is the interest in CH skewed by the distribution of power and wealth in the world? Are we at European facilities, for example, excessively interested in measuring European CH?
That's a really interesting question, Sonia. Thank you for that. And one of the things, of course, when we look at the politics and power and heritage and identities, these are really domains where we often also get into contested situations. And I would also like to draw on the social sciences, the humanities, in terms of when we look at cultural heritage, what constitutes heritage. I had a few slides in the beginning, but I didn't go into the anthropological understandings and variation, diversity in terms of understanding what is heritage and how we define it, and how particular monuments, for example, get into the national heritage listings, whatever they are called. As I mentioned, I was in Japan recently, and have been, of course, working in the European Union context, in Cyprus and elsewhere, in the UK, where I used to be, in Scotland, England, before coming here, and originally being from Finland. There are interesting differences in terms of how we see heritage and how we see its preservation. If you look into, and I won't go into detail, but look into how in Japan the historical castles are preserved, treated, and so on, and how this may sometimes leave us puzzled in a European context where we think that a moment frozen in time is what we want to preserve in terms of our castle or an artifact. Whereas in Japan, the view is quite a bit different. So I'd encourage you to look into this, as well as then, of course, there is a number of key texts, and I can, if you contact me, I can pass you some further reading on heritage in the context of politics. It's a really key domain and huge domain, and we need to be very conscious and aware of the historical uh, specificities and the power plays and so on. I hope that goes some way of answering your very complex question. I think this is actually worthy of a thesis of its own, a doctoral thesis.
The question from Dr. Shirin Akhter, I'm not sure I understood fully. I will read it. If you could let us know whether your laboratory is using CRM for human hair analysis.
I don't know if you're able to, whoever asked the question, to explain a little bit more, maybe by
You, yes.
orally or writing a bit more. No?
Well, I invited to unmute, but okay, no response.
Maybe some text. Perhaps we wait for some further information on the chat, if I may suggest, Natasha.
Yes.
Okay. Any further questions? In the meanwhile, when you're checking, of course, in terms of hair analysis, we exhaust all techniques that we can in the lab, as I mentioned earlier, within the context of particular questions. Of course, in archaeology, if one gets into the business of characterization fully, it will never end. So we really need to focus on key questions and what we want to find out in a particular context, whether we are looking at parasites in a context of irrigation agriculture, any particular increases, or whether we're looking at human heavy metal exposure or looking at let's say growth disturbances in childhood, comparing different populations and using synchrotron radiation to do virtual histology to avoid the necessity of cutting the precious samples as previously had to be done. So destructive analysis in that sense, and so on and so forth.
And
Any
a quick question from me. Maybe if you could give us a few steps for a user who is not familiar with synchrotron and who thinks it's the best chance to do the research there, what should be done? I mean, what are the steps? Who to contact? What to learn? What to get prepared for?
That's a wonderful question, Natasha, and I would even hazard to say that this perhaps can be answered also more generally for all domains. If you are working in a context that you suspect, you think that synchrotron radiation could provide some critical answers, but you don't know how to go about it. First of all, you're not alone. This is a very well-known situation. So what we're doing in many different contexts, and now most recently in the context of the Sunstone EU project. So I will put it later on in the chat, Sunstone. You can contact Sunstone. You can look at these projects and get trained. We can put you in touch with beamline scientists. We can put you in touch with mentors. You can contact me so that I put you in touch with the right people. We have people who are helping you all the way from ideation, developing your idea of what you would like to do, exploring, and we call some of these workshops the crazy ideas workshops. And this is something that the PSI in Switzerland also did when they set up the XFEL facility there. So it's basically about freely exploring as a team of different experts with different backgrounds what could be done. And then you get to the research design and contacting the beamline scientist for feasibility and so on and so forth. There's a lot of help in writing beam time proposals. Another thing that I would like to mention is there's a lot of recorded talks and presentations also online, so you can look at those. And for example, from Sesame website, you can check out the Sesame User Committee, the SUC, and each committee member has a specialization domain, whether it's health or material sciences or archaeology. And it has been agreed that each representative, they represent Sesame members, such as Jordan, Egypt, Cyprus, and so on. But they also are very happy to hear from you as potential future users, as according to their domain, to give you advice. And another aspect that was mentioned, I think, by Simon and Sekazi earlier during the training is the LAMP program. So the LAMP program gives funding for faculty student teams, the so-called FAST teams, to go to synchrotron facilities for 2 months and to explore what could be done. So really an intensive mentoring period. Another thing you can do is you can contact us and come and visit in the Cyprus Institute at the feeder facilities and have a look at, for example, in the context of an Erasmus, what could be done at synchrotron facility and what preparatory work would need to be done at laboratory facilities, feeder facilities, such as the ones that we have in Cyprus. But yes, please, feel free, any of you participants, to contact me for further links to resources. There's also a survey that I conducted for the International Atomic Energy Agency on resources online available for cultural heritage and synchrotron radiation domain. So there's a lot that that can help you in the way, but there's no beating a good conversation, either online or over coffee. So don't feel that you have to read absolutely everything on these resources. No one expects that. Be brave, contact us, look at the training workshops online or in person that we are organizing under the Sunstone EU project. I'll send a link in the chat and get in touch. And that's how one of the most brilliant journeys in many people's careers started, having a simple conversation in a corridor or over a coffee. So don't be shy, get in touch.
Thank you for this very encouraging answer. Now we've got a few questions. I think we have time for one quick answer. Milos Vujicic is thanking, as many others appreciate the presentation, and he's asking about any latest insider news on the wonderful and thrilling site of Koirokoitia. I mispronounce it probably.
Hirokitia, Hirokitia. That was wonderful.
Sorry.
I understood exactly what you meant, Natasha. So compliments on it's a bit of a mouthful, but yes, I think the latest news was that the excavators of Hirokitia were presented with a Cyprus Archaeology Award by the Republic of Cyprus president about 10 days ago. So there are many wonderful developments there, ranging from augmented reality experiences as well. That's one of the things that a colleague of mine here at the Cyprus Institute is busy with, as well as the studies of human remains from Hirokitia that I've conducted, and many French colleagues have also been busy with in the past. So it's a long-standing site and many more news to come. So thanks for that question. And certainly synchrotron radiation is applicable also on that site. So thank you. And do come to user community building events and find out how you can use synchrotrons wherever you are, online or in person. It's a
Yes.
family and we wait for you.
Thank you so much for this wonderful presentation and the answers. If you have the time, if you can answer questions in chat, or maybe you allow participants to contact you by email, we'd be very grateful.
Absolutely. I'll pop my email there and I will go through as many questions I possibly can before my next meeting. And if your question doesn't get answered in the chat, my email is there, so please do get in touch.
Thank you so much.
Thank you very much for having me.
Yes.